So today we're looking at threesome. Given an integer array nums, return all triplets, such that I does not equal j, I does not equal k, and j does not equal k, and the value at I, the value at j, and the value at k equals 0. Notice that the solution set must not contain duplicate triplets. Let's move this over to IntelliJ and then dive into it. Cool, so here's my main class. I have an array from -1, 0, 1 to -1, 4. And the description of the problem. Then the example scenario where if the array is -1, 0, 1 to -1, 4, the apple will be the triplet of -1, -1, 2, -1, 0, 1. Okay, so let's get to the go ahead and break this down. So this isn't much different. This is very similar to the two sums problem, where in the two sums problem we're iterating over a list and we're checking if the matching pair exists in that list to hit our target number. This is very similar in that our target number here is 0. The only real difference is we have 3 values to account for, and we have to account for repeating triplets. So essentially, the easy way to visualize that is, let's say we have let's do -1 and 0. Within this, there's one triplet that'll give us 0, which is 1, -1, and 0. Now, there's 3 1s here. So technically, there's 3 triplets in here, but they're all the same of 1, -1, 0. So we need to account for duplicate starting values is what we need to account for. Since this is a medium level problem, we'll probably have to do something a little bit more complicated than simpler solutions, where we'll probably have to do the double pointer approach, where we'll probably iterate through every value, and we're going to have to account for any duplicates. So we're going to sort our array since it's not already sorted. And the reason we want to sort it is that's the easiest way for us to go through and account for any duplicates, right? So we're going to for loop through it. And then as we're going through it, we're going to have a check somewhere where we're going to check, hey, is my value here the same as the value to the right or to the left, depending on how we want to break it down? Essentially because once we find a triplet, right? Once we find a grouping that equals 0, we don't want to have the exact same triplet if we start with 1 again. Right, meaning if we start with 1 here, we start with the 1 here and we find the triplet, we don't want to move to this one and then say, okay, cool, here's the next one, and then move to this one and say, oh, it's the next one, when all these 3 produce the exact same triplet. So we need to account for duplicate starting values. And we specifically want to call it starting values because if we start with the same value, and we know that for one of them, we already have a triplet. That means that for all of them, we'll have the triplet, right? Because we know that the combination of 1, -1, 0 exists, and that works. We know that regardless of which one we start with, it'll always give the same triplet combination. So we want to account for that, as opposed to the values 2 and 3, where those are more controlled by the first value. So let's do that, and we'll also use a double pointer. With a double pointer, and the reason we're using this is because it's sorted and because better control and manipulating the current sum. And exactly what I mean by that is we have the initial value of our for list, right? The initial value, the current index. We're gonna have the current index, and then we're gonna add the left and right pointer. And as we add these values, we're going to check, does it equal 0? Right? We're going to be checking, hey, is this equal to what we want, which is 0? And if not, we're then going to check by how far is it? How far off is it? Right? And then from there, we're going to either move our pointer, the left pointer or the right pointer. And the reason we care about that is that our left pointer will be the lower values and our right pointer will be the higher values within our array, because we sorted it, right? And because we sorted it, we know it's going to go from the least value to the greatest value. Okay, and here we create a list of lists, integer, and we'll call this triplets, and it'll be a new, we'll do a linked list. We could also use a set, but the logic here is a little bit more complicated, and I feel for this one's completely fine. But yeah, if you want to speed it up, you could also use a set, and that will take care of any duplicates. But for now, just regular list inside the list as a linked list is completely fine. So now we're going to iterate. So for create integer, we'll call it current index. Let's go to 0. While current index is less than nums.length minus 2. And we're going to do plus plus current index. And the reason we want to do nums.length minus 2 instead of just nums.length minus 1. We're going to get to the third to last item because we want the last 3 to be a valid triplet if the values add up. So if we do minus 1, we'll get to the last 2 values and we'll get errors going down the line. So we need to account for the fact that instead of a double, we're here doing for a triplet. Count for duplicates. So for this, we need to check if the current index equals 0. If the current index is 0, or the value at nums of the current index does not equal the value at the current index minus 1. So essentially what we're doing here is if the first, or if no duplicate. So this will run during the first iteration because the current index is 0. And once it's 1, it will check the next half, which is just if nums of the current index does not equal nums of the current index minus 1. So essentially, as we move forward down the list, it'll check the previous value to see if it is the same as the current value. We're doing this because it's sorted, and as stated previously, we don't want to start with the same value. So here, we're gonna create our pointers. Left pointer, and then integer right pointer. And we want this one because we want the last value, as opposed to here where we did nums.length minus 2, because we want to account for the start of the triplet being the third to last index. Here we start at the end because that's the last value, right? So it'll be the current index, the left pointer, and then the right pointer, and as we add them all up, we'll go through the list. And here we'll have integer called target sum, and we'll set that to the negative value of nums at the current index. And the reason we do this is we want to take the same approach as twosum. Where in twosum, we were checking if there's a combination of values that'll hit 0. And the way we're doing that is saying, hey, is there a corresponding pair to make us hit 0? It's a similar approach where we have the target sum and we set to negative because we're going to be adding the values at the left and the right pointer and checking if it's 0. And if it's 0, then that's a valid triple. And we're going to go ahead and add that to our list. And if not, we're going to continue going through the list. Use pointers to get triples. So while my left pointer is less than my right pointer, we need this because we're going to be shifting our pointers as we go through the list. We're going to check if the value of nums at left pointer plus the value of nums at the right pointer will be equal to our target sum. Right? So that means if we get inside here, this is a valid triple. So what we're going to do is we will do triplets dot add. And now because it's a list of lists, we're going to do this array as list. So arrays dot as list. And we will add nums at left, nums at right, and the nums at the current index. And right, cool. Now order here kind of matters because the current index is the first value in our loop, the outer value, the left value right next to it, and the right is going to be at the very end of our array. Next, what we're going to do is we're going to be moving our pointers. So while the left pointer is less than the right pointer, and the nums at the left pointer while the left pointer is less than the right pointer, and the value of nums at the left pointer is the same as the value of nums at the left pointer plus 1, meaning 1 to the right of it. What we're going to do is we're going to be increasing the left pointer. So plus plus left pointer. We're going to do this because we're going to be advancing it forward and we don't want any duplicates. And now for the same thing, but for the right hand side. And this we do right pointer and we do right pointer again. But this time instead of plus, it's minus because this is the right hand side. And then minus minus right pointer. And then what we need to do is still move them one more time. So left pointer, minus minus right pointer. And we have it like this because here we move them to the very spot where we know it's a duplicate. We still need to move it one past it. And then we right, there we go. I had it outside of my if. Then we have an else if nums of our left pointer plus nums of our right pointer is less than the target sum. What we want to do is we want to move the pointers. So left pointer, because we want to incrementally increase the value. And then else, we're going to go ahead and lower the right pointer, because if it's the combination is less than the target sum, we want to incrementally by a small amount increase it, or if it's bigger, we want to decrease it, right? Because moving the left pointer to the right will always increase, but moving the right pointer to the left will always decrease, because we have a sorted array. And at the very end, all we need to do is return the triplets. So let's see, where is it? Here, here, here. And perfect. Return triplets. Okay. Cool. So now back only code, paste it, hit run. Cool. And then just submit. Cool. 31 milliseconds, be 65% of users, and 70%, 46% of users hit the speed. Cool. So that's a slight variation on the regular two sums. It's okay. It takes a little bit more thinking and kind of a little tricky to know to sort it. I remember when I first started thinking, hey, can I even sort these? Like, is it allowed? Right? Like in an interview, if I just sort this array, will they deduct points, or think, you know, it's just taking shortcuts and I don't know what I'm actually talking about? But it's fine. For a question like this, it's kind of expected. And you shouldn't think of like, hey, I'm sorting it like this being a shortcut and that I shouldn't be able to do it. If anything, it just shows that you understand how to use the language. I only think that sorting would be a bad thing to do if the question itself is like about a sort, like maybe a binary search, binary sort, or, you know, reduction or anything like that. In that case, sure, probably using a predefined sort isn't recommended. But for a case like this, it's completely fine. But yeah,